In this presentations, we are going to discuss about the virtual machine in operating system. Here, we are going to discuss about the overview and history of virtual machines, benefits and features of virtual machines, building blocks. The objective is to explore the history and benefits of the virtual machines and to discuss the various virtual machine technologies. So in this overview, the fundamental idea of the virtual machines is an abstract hardware of a single computer into several different execution environments. So similar to layered approach, but the layer creates virtual system on which operating systems or applications can run. So here the several components are available. The first one is a host. So it is an underlying hardware system, and the virtual machine manager, that is an VMM. So it is an other name is hypervisor. So it creates and runs the virtual machines by providing an interface that is identical to the host. And third parameter is guest. So it is a process provided with the virtual copy of the host. So in this single physical machine can run multiple operating systems concurrently, each in its own virtual machine. So in the system model, actually it is in a non-virtual machines. It has a single kernel and the hardware elements can access through the kernels and the processors. So in this virtual machines, the process can be separated. So in that, and the kernels is also separated. So each kernels is worked with the each virtual machines V1, VM2, VM3. So in this implementations of the virtual machine, so here they vary greatly with options including that's in type 0 and type 1 and the type 1 hypervisor and type 2 hypervisor. So here in this type 0, the hardware based solutions that provide support for a virtual machines creations and managements via the firmware. So in this next type, the operating systems like software built to provide a virtualizations. So in this next versions also include the general purpose operating systems that provide the standard functions as well as the virtual machines manager functions. So in this final type, it has the applications that run on a standard operating systems but provide the virtual machines manager features to guest operating systems. So in this implementations is also have the variations, that is the para virtualizations. So here the techniques in which the guest operating systems is modified to work in cooperations with the virtual machines managers to optimize performance. So in this programming environment virtualizations, VMM do not visualize real hardware but instead create an optimized virtual machine. And in these emulators allow applications written for one hardware environment to run on a very different hardware environment, such as a different type of CPU. So in this finally the applications containment, that is have not visualizations at all but rather provides visualizations like features by the segregations applications from the operating system. So it's also making them more secure and manageable. So much variations due to breadth, depth and importance of virtualizations in the modern computing. So here the history of VMM is it's the first appeared in the IBM mainframes in 1972. It allowed multiple users to share a batch oriented system. So it's the formal definitions of the virtualizations helped move it beyond IBM. So in late in this 1990s, Intel CPUs are fast enough for researchers to try virtualizations on general purpose PCs. So that is the example is it's an Xen and VMware creates technologies. So in this virtualizations has extended to many OS and CPU and VMM benefits and features of VMMs. So here the host systems protect from VMs, VM protected from each other. So that is a virus less likely to spread. So here the sharing is provided through VIVA shared file systems volume and the network communications, and the freeze and suspend running VM. So it's the main benefits. So they can move or copy somewhere else and resume. So the snapshots of a given state able to restore the back documents and the state informations. And the clone is the next key point. So it is by creating copy and running both original and copy. Then create and a grade for OS research, better system development efficiency. So run multiple different OSs on a single machine. It is really efficient. And then next benefits are templating. So here create the OS and the applications VM. It provide the customers and is use it to create a multiple instance of that combinations. So next one is live migrations. So here move a running VM from one host to another. It also support the cloud computing. The applications can be performed by the API. So in this building blocks generally different and difficult to provide an exact duplicate of underlying machine. So especially in this building block, if only dual mode operations available on the CPU, but getting easier over time as CPU features and supports for VMM improves. So most VMs implements virtual CPU to represent state of the CPU per guest as guest believes it to be. When the guest context is switched into CPU by VMM, information from the virtual CPU loaded and stored. So several techniques are described. So the first one is the trap and emulate. So in this dual mode, CPU means is a guest executes in the user mode. Here the kernel runs in the kernel mode and the guest executes in the user mode. So not safe to let the guest kernels run in a kernel mode too. So the VM needs two modes, the virtual user mode and virtual kernel mode. So both of which run in real user mode. So actions is actually taken in guest that usually cause switch to kernel modes must cause switch to virtual kernel mode. And how does switch from the virtual user mode to the virtual kernel modes? So that has the following procedure. That's a trap and emulate process. So here the attempting a privileged instructions in the user's mode causes and the error. So in that is a trap. So in this VMM gains the control and analyzes the error and executes the operations as the attempt by the guest. So it returns the controls to the guest in the user mode. So that's a trap and emulate. User's mode scores in the guest runs at same speed as if not a guest. So but the kernel's mode's privileged mode code runs slower due to trap and emulate. So the CPU adding the hardware supports modes, CPU modes to improve the visualization's performance. So the trap and emulate visualizations implementations is given. So here the VMM and the guest, actually user mode and the kernel mode. So the emulations process done after the trap function. So if any particular error is identified in the guest side, that is in user mode, that privilege to instruct the trap errors, and that can be processed and updated by the kernel mode in the VMM. Then it is returned to the user's modes to further after the continuations of the further process. So in this building block, a binary translations is an essential because some CPUs don't have clean separations between the privileged and non-privileged instructions. So the earlier Intel are among them. So here the CPU designed for a calculator. So in this backward compatibility means difficult to improve. So in this considers the 86 POF instructions loads the CPU flags registers from contents of a stack. If the CPU is privileged mode, all flags replaced. If the CPU in the user mode on some privilege, that means on some flags replaced. So other similar problem instructions we will call a special instructions. So is the cost trap and emulate method considered impossible until the 1998. So that problems can be handled by the special instructions. So binary translations solve the problem. This kind of solutions is given. So the basics are simple, but the implementation is very complex. This has the following procedures. If the guest of virtual CPU is in the user mode, the guest can run instructions natively. If it is in the kernel modes, the guest believes the kernel's mode. So virtual machines actually examines every instructions guest in about the executable by reading a few instructions ahead for the program counter. The program counter will give the address of the next instruction. So based on that instructions, the virtual machines examines every instructions. So in the second step, non-special instructions run natively. So the special instructions translations into new set instructions that perform equivalent task. So the implementations by the translations of code within the VMM isn't very efficient, and in this performance of this method would be poor without optimization. So optimization task is essentials that can be performed by the catching, that's in translations and testing showed booting. So in this process of binary translations, virtualizations, implementations after the optimizations. So the optimized codes. So in this VMM reads the instructions as special instructions. So in this nested page table, it contains the common method. So it is a trap and emulated informations. So which instructions to be trapped and what kind of emulations, what kind of actions to be taken for the further. So this transactions informations and the binary translations informations, everything hold in the nested page table. So VMM maintains the per guest to represent the guest page table state. So for each guest we have to maintain the nested page table. So in this hardware assistance, Intel added new virtual machine 6 instructions in the 2005 and AMD V instructions in the 2006. CPU with these instructions removes need for binary translations. So in this virtual machines define the CPU mode, guest and host. Since VM can enable host mode, define the characteristics of each guest VM, switch to guest mode and guest mode on the CPUs. The guest mode like that it is a running natively sees device. So nested table contains the informations about the which are interconnected and the overall virtual address informations. Thank you.